A technical conference without a technical glitch, wouldn't it? But like 7 minutes later, we're about to start, so welcome everybody. It's great to see a full crowd like that, early in the morning on a Saturday. Hi. Yeah, my name is Nick. I work at a Bulgarian company called Obsidian, and we are a consultancy agency. So I would call myself a full-stack developer. And yeah, welcome to JS Talks. We'll be talking about, you guessed it, JavaScript stuff. Specifically, we'll be discussing web rendering strategies today. What do I mean by web rendering strategies, and where do we start? Let's keep things fairly simple from the very beginning. We have the typical client-server architecture, where we need to transmit information between the client and the server. So obviously, we just want to access some sort of a website. In order to do that, we need to ship some assets from the client to the server in order for us to be able to actually use the website. There are two broad categories of things or assets that we need to transmit from the backend or the server to the front end or the client for our website to work. The first one is the so-called static assets. Static assets include stuff like HTML, CSS, pictures, songs, whatever, icons, pretty much assets which are just shipped and then displayed on the screen without any further logic being applied on top of it. But of course, we are JS Talks, and having modern websites we can't do without a ton of JavaScript. And for the most part, JavaScript is the language of the web. So this is the thing that will actually be executing parts of our business logic and actually delivering the full experience to our clients. When it comes to the static assets, things are fairly simple. You just deliver them to the client device. You can't optimize that much from the whole process of delivering those static assets, because they need to be delivered. But when it comes to JavaScript, and boy do we have a lot of JavaScript lately, we need to figure out if there are better ways to deliver that JavaScript to our clients, because otherwise we'll get that nasty spinner for 5, 10, 20 seconds, depending on our user and our mobile connection and whatnot. So in this talk, we'll mostly be discussing the pros and cons of the different approaches, specifically server-side rendering, client-side rendering, and all the hybrid approaches available to us as developers, with their strong suits, drawbacks, and hopefully by the end of this talk, you'll have a better understanding of the core web rendering strategies, and you'll be able to choose appropriately in your next project. With everything in life, we have, of course, we need to maintain some sort of a balance, and there are pros and cons, as I mentioned. The main two ones, when it comes to delivering websites, are cost and performance. And by performance, this is some sort of a general term. That includes, let's say, the initial delivery of that website to our client, and then the actual usage of that product by our client, so the whole experience. Of course, one cannot, they kind of go hand in hand. Because what do I mean? Imagine that you're at the backseat of a car, traveling on a 3G connection somewhere in the countryside, and you want to check out this new application. If you click on a link, and then what happens? If that website is utilizing client-side rendering, that would mean that you need to ship a huge JavaScript bundle in the excess of, let's say, 3, 4, 5 megabytes nowadays from some sort of a server, let's say in Poland or in Finland. It may not be in Europe at all. You need to deliver that somehow through that spotty 3G connection to your actual client, so that the client can, first of all, get that JavaScript, parse that JavaScript, and then execute it. After that, your site becomes interactive. Obviously, this is kind of the cheap way of doing things, because costs are pretty low for us as developers, simply because we do not have a server running in the background delivering optimized assets to our client. We just have some sort of a cloud-based file system. And that's why we can deploy client-side application directly in, let's say, AWS S3 or any other cloud file system. We do not need a server. On the other hand, if we were to have, let's say, some sort of a server-side rendered application, we would have had a server which is doing the bulk of the work somewhere in the cloud, let's say, and then delivering as small of a bundle as possible to our client, reducing dramatically the initial load of our application. And study after study shows that if the average user opens a web application and doesn't see anything happening for access of 2 to 3 seconds, he's very, very likely to never use that app to begin with. And we need to kind of get into business mindset here and leverage the pros of server-side rendering if we wish to deliver faster initial loading, and by doing that, hopefully, to create a greater future user base, which will be, hopefully, bringing our company or our product future revenue, although that may cost us some money. But, as I said, pros and cons, let's discuss all of those during our presentation today. But, taking a step back, first of all. What you see on the screen may sound as something irrelevant to our talk, but give me a sec. It's one of the most influential devices when it comes to delivering mobile applications, or the mighty iPhone. Not any iPhone, this is iPhone 5, 5S, 4, something like that. So that's like 7 to 8 years ago. Notice the design of that device. When it comes to the sides of that device, they are flat. So we do not have round sides of the device, they are perfectly flat. What are the pros of that? Well, the device is easier to pick up, and you're less likely to drop it and break your screen. But it's less comfortable in the hand, because you have all those angles. Then Apple, let's say the most influential company nowadays, decided to switch designs, to switch to the other approach, with the round sides. This is, let's say, iPhone 6, 7, 8, up to XR. By doing that, of course, you receive the pros of the device being very beautiful and comfortable to hold, but it's way more slippery, and you're more likely to drop it and break it. Then, nowadays, with the latest iPhones, or that being the 14 Pro Max something, we once again have the flat sides, bringing back the design decisions from almost a decade ago. What I'm trying to say here, and what I'm trying to draw the following analogy. One is not necessarily better than the other. I mean, when it comes to designing a mobile phone, you don't have much of a choice. You can either have flat sides or round sides. But one is not necessarily better than the other, simply because both of them have pros and cons. And as Apple, and in this case history repeats itself, and so does the web. Now allow me to take you on a brief journey of the web, starting from the very, very beginning up to now. And let's see if we can notice some sort of a pattern going on, and whether we are potentially reusing concepts from 35 years ago. In order to do that, we're beginning with a proposal here. And as far as proposal goes, this is one of the better ones for sure. This is information management proposal from no one else but Mr. Tim Berners-Lee. He's working at CERN, or the so-called father of the internet. And the year is 1989, so almost 35 years ago at this point. Mr. Lee has the following issue on his hands. He has all those colleagues and all that information that he wishes to be easily transmittable and easily shareable between him and his colleagues, but he doesn't have the technology to do that. So he comes up with that proposal. In that proposal, you see very, very familiar concepts as to what we're using 35 years later. This is part of that proposal. So he proposes that we'll have client devices, or the so-called browsers, and we'll have server devices, or the so-called hypertext servers. Not only that, servers would be able to communicate with other servers. Not only that, he's the first person who comes up with the idea of the modern server-side rendered application. What I mean here is that, let's read what it says on the slide. Dummy hypertext server makes existing database look like hypertext to the browser. In other words, let's say the browser device wishes to get some data from the server. So you send a request to that particular server. That server takes that request, makes another few requests, let's say to some databases, constructs the data, and brings it back. So essentially we have server-side rendering 35 years ago. And remember, we do not have any JavaScript at this point. JavaScript has not been invented. Following that, we have a few key events. The first of all is Mr. Lee, with some colleagues, decides to come up with something, some regulating governing body on top of the web. Because as you can imagine, the web grows dramatically. The web is becoming more and more influential, starting in 1991, and it literally explodes from that point on in terms of user base and bandwidth. So he comes with the W3C, or the World Wide Web Consortium, which is a governing body simply regulating what can and cannot happen on the internet, mostly in HTML as a standardization body. Because currently, the year is 92 and we don't have anything else. Of course, a few years later, in 94, CSS happens, or those so-called infamous cascading style sheets that we're battling to this day. And the syntax, it may surprise you, but it's fairly similar to what we had 30 years ago. But both of those events are rather influential, but not as influential as the next person who comes on the stage. This is Mr. Brandon Ike. Brandon Ike is a developer who's working at Netscape at that time. And one of his managers gives him the following task. You have approximately 2 weeks to deliver a proof of concept of some sort of a scripting language that will be used in our applications. Those are not web applications, just some websites at this point. And boy, does he deliver. Not only does he deliver in 2 weeks, but the core of those ideas are still with us 35 years later. So, yeah, very influential as far as people in the web go. From that point on, you can imagine that HTML takes a bit of a step back, and everybody's like, give me that called CSS and JavaScript, because we want to make everything interactive. We want to make everything beautiful. And by beautiful, that's kind of debatable, because probably you've seen sites from the 90s, everything is flashing, and you have all those colors and animations and whatnot. But CSS and partly JavaScript allow that to happen. HTML takes a step back. And everybody at this point is jumping train when it comes to having some sort of a web presence. And the more important ones are basically the corporations. As soon as the corporate world saw that they would get some benefits if they had a website, everybody jumps train, and we have another explosion, or we have the so-called .NET bubble. The .NET bubble is an economic event happening around the year 2000. We have just a lot of people very interested in the web, and we have a lot of money in the web as a whole, but that's not sustainable, and we have an economic crisis later on, not that important. But after that, and at this point, everybody is leveraging server-side rendering, simply because JavaScript is not yet that influential, not that many people write proper JavaScript, and a lot of the tools are simply not there yet. The first one on the stage is Ruby on Rails in 04, but that's quickly followed by all sorts of different tools and libraries, some of which are, literally all of them are still available to this day. We have the interpretations of an MVC server-side rendered application by languages such as Java, .NET, C#, Python, PHP, and so on. So at this point, we're still running everything on the server. The so-called single-page applications have not been invented yet. Everything is delivered from the server to the client with minimal JavaScript. And by having minimal JavaScript, you can imagine that the sites are not that interactive. And by not that interactive, what I mean is, every time you want to interact with the site, you need to click on something, and then a whole page reload happens, which is hardly an optimal web experience. But then comes 05, and Mr. Jesse Garrett comes up with Ajax, or a new way to write web applications. This is kind of the birth, or the formal birth of the single-page application, because at that point, the most impressive application on the web is Google Maps. Suddenly, in 04 or 05, you are able to open a map in your browser. You're able to zoom in, zoom out, pan around, move your mouse, which was not seen up to that point. It was revolutionary. And all that without a single refresh of the whole web page. Mr. Garrett just takes that concept and comes up with a formal proposal of some sort of an architecture which should be followed. In order to get the architecture, on the left we have the classic web application model, before Ajax, and then we have Ajax. The main differences include stuff like, first of all, when it comes to the classic web model, every single interaction with your website, or most of them, result in a full page reload, which may take a few seconds, and it's a very unpleasant user experience. But Mr. Garrett proposes that we should have an Ajax engine, or some sort of a intermediate level between our client and our server, and that the sole task of that Ajax engine would be to get user interactions from the client, send a request to the server behind the scenes without the page reloading. When the data is received back, it plugs it inside of our UI, once again, without the full page reload, which is key. And that makes websites way more interactive and way, way more polished, so to speak. Once again, we have the client web model, which is, we have some user activity. So you click on a link, that sends a request, the request comes back, you browse around, and as soon as you do anything, pretty much, you have the same thing happening over again, non-optimal. And we have the Ajax web application model, which is pretty much leveraging JavaScript as an intermediate level between your user interface and your server. And that allows the applications, the so-called single-page applications, to be important. And single-page application is nothing else but, roughly speaking, just an application which doesn't reload. So once you load it, you can do stuff around the user interface, and you wouldn't expect to see a full page reload. At that point, this is revolutionary. We are in 06, 07, something like that. And everybody sees the potential of delivering such applications. And the first applications are so successful that literally everybody's like, we should get rid of that server side. Everything should be single page, because we have all the benefits. The applications are way more modern, way more polished, and therefore they're bringing more revenue to us as companies or as developers. So after doing that, we have, this is kind of a slide that I stole from Ms. Drasner. She's a director of technology at Google, so she knows way more about those things than I do. But she came up with that, let's call it a dependency tree, between all the different tools which were born from that point on. We can roughly divide them into precursors, or this is the old MVC pattern or and server-side rendering in Rails, the revolutionary library jQuery, and then the first wave is born. The main player here is AngularJS, not the new Angular, but the old one. But from it, the second wave includes stuff like React, Angular, and Vue, or the three most influential current frameworks or libraries, when it comes to delivering single-page applications. The third wave is something that we'll be talking about a bit later in our presentation. So, let's try to follow our story. At this point, everybody's like, give me some of those single-page applications. We want client-side rendering. And more JavaScript starts to be shipped to the browser. That results in something that some of you may have seen in your day-to-day careers. We have those huge bundles, and you practically cannot ever know what is inside of it. You can have a rough idea, but we have dependency of dependencies of dependencies. It's a complete mess. We have duplication. We need to explicitly check stuff. It's a whole mess. And that results in an exponential growth of the bundles, the JavaScript bundles that need to be delivered from the client, from the server to the client. And as I mentioned in the very beginning, imagine you being on in the backseat of the car on a 3G connection, and you want to open a website with a 5 megabyte JavaScript bundle. It can take like 20 seconds. You're very likely to have closed the application at this point. And the application is losing a user by doing it. So at this point, as I said, everybody's waiting for that bundle. Everybody's just, the website is not responding, and you're literally seeing a blank screen. You don't even have some, a loader or anything. You see a white page, nothing else. Obviously, we should do something about it. We fast forward a few years, and the year is something like 2014, and some people are starting to notice that, wait a minute, like 25 years ago, at that point in time, we had the solution. We had server-side rendering. I mean, can we leverage concepts from 25 years ago and efficiently improve our web applications and the whole application experience? It turns out that we can, of course. And the key players here include libraries, or rather frameworks, such as Next.js, Nuxt, kind of unfortunately named. I've always been puzzled why we have Next.js, Nuxt.js, and Nest.js. It's a complete mess for newcomers. But yeah, that's a story for another day. And we have Angular Universal, which is like the third key player. Basically, Next on top of React, Nuxt on top of Vue, and Angular, of course. Those tools see the benefits of having server-side rendered applications. Mostly in that, the application is delivered to the initial loading. The initial load of that application is way faster when compared to a single-page application, therefore delivering a better overall experience. So, a brief timeline of the web goes something like this. We have the birth of the web. We have governing bodies such as the W3C being born. We have JavaScript coming into the scene. At that point, everybody is using server-side rendering because there isn't the client-side rendering yet. Stuff like Rails on top of Ruby are the best and the most widely used web technologies. But then Mr. Garrett comes up with Ajax, the revolutionary new way of communicating between a client and a server without the need of explicit reloads. And following is the birth of React Angular Vue, or the so-called the three influential single-page application libraries nowadays. And of course that we come a full circle, and currently the hottest technologies include Next, Nuxt, Universal, which are leveraging concepts from 30-something years ago. So we kind of did a full circle, just like the iPhone. What I'm trying to say here is that there isn't a necessarily better approach when you're choosing between server-side rendering and client-side rendering, because one has some benefits, the other has pretty much the same benefits but has drawbacks. And now let's dig a bit deeper into technical stuff so that we can see what exactly are those pros and cons. In order to do that, first of all, some housekeeping. Let's come up with some terms. First of all, we'll be using SSG, standing for static site generation, for static site generation. This is delivering web applications which are essentially static assets. Pretty much when you're building your application, when you're deploying your application, you pre-build or pre-generate every single web page that a user may possibly go into. You get those pretty much static HTML and CSS files mostly, with minimum JavaScript, and cache them on your server. And when a new user comes to your server and wants something, you directly give them the already done assets. This is, as you can imagine, as fast as it can get, because you're literally serving text over the browser. You're not sending any JavaScript whatsoever. We have SSR, or server-side rendering. In this case, we have the server doing the bulk of the work. The server can be using any language, but in today's talk we'll be focusing on JavaScript. So for server-side rendering, for example, you can use React on the server, Vue on the server. You can also leverage Node.js and stuff like that, but any server-side technology. And of course we have CSR, standing for client-side rendering, or this is the other way around, the complete opposite of the spectrum, where the client does the bulk of the work. Pretty much you're shipping your whole JavaScript bundle to the client, and it's the client's task to get that JavaScript, parse that JavaScript, and execute that JavaScript. Some key metrics here include FCP, standing for First Contentful Page, or this is the delta or the difference between clicking the link for that website and actually seeing something meaningful on the screen. It's not necessarily the full web page, but you see something relevant on the screen. So your users are not left with a blank screen, you can see something. And we have TTI, which stands for time to interactive, or this is once again the difference between clicking on that link and the user is able to click around, to navigate, do some stuff. Having those key metrics in some terms, let's once again take a step back. We have a fairly simple setup, client and server. Let's try to see what SFG, or static site generation, does for us. In static site generation, as I said, during the build of your application, so pretty much immediately before deploying that application, you are preparing ahead of time every single web page that your users may potentially want to visit. And you get those static web pages and you cache them somewhere so that you can easily deliver them later on. As you can imagine, and a key hint here is the first letter, it's static, so you cannot have anything dynamic. In other words, you cannot have user accounts, you cannot have shopping carts, you hardly can do anything, quite frankly. Because nowadays, like 99% of stuff on the web is dynamic in nature. You do not simply have some sort of a static blank document that you want to serve. When it comes to the HTML and CSS that is delivered, as you can see, when we're using server-side and static-side generation, when a client requests something from our server, the server is returning complete HTML pages full of content and complete style sheets so that we can get them beautiful. And let's finally discuss those pros and cons that I promised you earlier on. First of all, pros. We have amazing initial loading times. Why do we have that? Remember, we just have static assets already there waiting in our server. You can call it a file system actually. It doesn't need to be a server. It's literally a place that just gives you static assets. It returns complete pages, which in itself enables superb search engine optimization performance. That is because imagine you being in the shoes of a web crawler. So let's say Google's bot or Bing's bot or Yahoo's bot. When you see that HTML, it's full of data, so you can easily traverse that HTML and index it properly. So stuff like H1, meta tags would already be there so that you can index it properly. When it comes to drawbacks, there is mostly one, but it's a huge one. Things cannot be dynamic. We cannot have user accounts, we cannot have dynamic data, we cannot have shopping carts, we can hardly have anything relevant for a web experience which users are expecting in 2022. And it's a bit harder to set up, just because you need to have pipeline set up so that they pre-generate everything and cache it somewhere. Looking at the networking side of things, things go something like this. You issue a request, let's say, give me the index page of our web application. You immediately get that static HTML, and there it is. We have the first contentful pane, because you have all the data already in that HTML. As soon as the browser, or let's say your Android phone or whatever, gets that HTML, it's almost immediately on the screen, because it's in there in the data. And we have the delta between FCP and the time to interact with is very minimal. Usually because in static sites, we may choose to not have JavaScript altogether, or usually we have just some minor stuff to add, just a touch of interactivity. But the delta between FCP and TTI is very minimal because we are delivering just as small of a bundle, of a JavaScript bundle as we can. Okay, taking a step back again. Client and server. What does it mean for us to be server-side rendering something? In server-side rendering, each time the user wants to do something on the screen, let's say navigating to a page, you click on a link, that issues a request to that server. The server gets the request with all the user cookies, user data, whatever timestamps, and constructs dynamically on the fly a customized response, which would be eventually delivered to our client. If you have a look at the HTML and the scripting which is delivered, or the assets which are delivered to the browser, the HTML once again is complete, because the server, remember, the server has already done the work. The HTML is a complete page, it just needs to be delivered to the front end. And when it comes to scripting, we have dramatically less in terms of bandwidth used for scripts, because the main purpose of the scripts which are being delivered if you are using a server-side rendering approach, those are the so-called hydration scripts. A hydration script roughly attaches event handlers to already existing HTML elements so that your page becomes a bit more dynamic in nature. But they're rather small in size. You're not shipping your whole dependency tree with 500 dependencies from that package JSON you have. Pros and cons, as usual, we have good loading times. We have a good loading time because usually the server is more performant than your device, than your client device. So the server is able to create a dynamic, fully featured and complete web page in terms of HTML and deliver it to your client as fast as possible. And we have less data being transmitted from the front end to the back, from the back end to the front end rather, resulting in small window sizes. And once again, this is great for search engine optimizers because have a look at the HTML. It's already there with all the data inside of it. So the bots can easily traverse that and index it properly. When it comes to disadvantages here, we have a couple. The main ones include that it's harder for development because right now you need to take care of a server which may be using, let's say, Python, it may be using .NET or Java or whatever. It can be a whole separate team with a whole separate language being utilized here. So you need extra team players inside of your setup and extra maintenance, and everything is associated with cost because it's more expensive to deliver, more expensive to deploy, more expensive to run the application. Everything is costing you money. But remember, if you're delivering a great user-facing application, chances are that you'll grow a future user base, which you can leverage them later on and turn that to some sort of a revenue stream. So you need to kind of make up your mind whether you want to invest some money early on in a server-side rendering setup and then reap the benefits from a greater user base. When it comes to networking, things are looking rather similar to the static side generation. The main difference here is that the page which is being returned is dynamic. So it's not the static asset in static site generation, but this time it's customized to the user request. So let's say the user adds something to a product basket or whatever. The response coming from the server is with that new item, so it's dynamic, customized to the user. And then we have the delta between FCP and TTI, or the first time you see something on the screen and the site becomes interactive, is, I would call it okay. It's not optimal because you still need to ship those hydration scripts to the browser, but it's way better when compared to client-side rendering. And speaking of client-side rendering, let's talk about it a bit. In client-side rendering, this is arguably the easiest way to develop an application and to deploy it and to run it. The story goes something like this. You have the client, you ask the server for the web page. The server, it's not necessarily a server, it can be just plainly a file system. It delivers, let's say, one HTML file, which usually is literally an empty div. Most of you have seen that, div with ID of root, that's it. And it's the task of that huge JavaScript bundle that you're delivering to your client to execute and then construct a whole HTML tree and plug it inside of that div with ID root placeholder. So you can imagine that if you're running a 5-year-old Android device, the whole process of downloading that, parsing that, and executing that can take in excess of 10-15 seconds, really unoptimal. Pros and cons is zero. We deliver a great app experience this time. We do not ever have to reload the page. Everything is happening on the client. Everything is fluid, everything is modern, everything is nice. And it's easy to develop because this is the standard way of developing web applications still to this day. And all the tools are there for us. They're rather easy. And remember, we do not need to have a server altogether. But when it comes to drawbacks, we have the possibility, and I should say rather the probability of our application being slow to load, especially initially, because you just need to deliver all those assets through the web, through the network, and then you're kind of left on the mercy of your client device. If it's an old device, it can take literally forever for you to see something on the screen. And while you're waiting, this is key, you just see a blank white page, nothing else. And we have poor search engine optimization metrics because, look at the HTML. It's empty. What would you index on top of it? You do not have any information there from the initial request. Looking at things from the networking side, we usually have a GET request that returns us all the necessary files, including that infamous huge JavaScript bundle that I'm mentioning for 1,000th time today. That JavaScript bundle, somewhere along the lines, we have the first contentful paint, but then we have a huge client rendering blocking event, which is the parsing and execution of that huge JavaScript bundle that we have. And this results in a huge difference between the first contentful paint, or rather I should say the blank page that you see, and the time to interact with. Because remember, your device needs to get all the data, parse it, execute it, display something, and make it interactive, which obviously is a costly process. So how do we make a choice? Well, things are, I hope, a bit simpler now for you, but let's see. Static site generation. This is suitable, once again, for static content only. So we can kind of rule out 99% of the current web, because everything is dynamic in nature nowadays. We have superb initial loading and search engine optimization, because quite frankly, we are just leveraging a file system in the web. We're not doing anything dynamic on the fly. If you want to use server-side rendering, this is good for dynamic pages, and search engine optimization and loading times are fine. And they are fine when you're comparing that to client-side rendering applications. In those, you deliver an amazing overall web experience, but the key thing here is that the initial loading time may be very, very suboptimal, and therefore the SEO would be lacking as well. So, in your day-to-day job, sometimes you have to tackle some sort of an issue. Let's say a new project comes along with some requirements, and you have some issues that you need to tackle. Let's see what some of those may look like. If you're experiencing poor search engine optimization performance, so your site is not showing up in Google properly, you may want to switch your application, because chances are that you're using client-side rendering. You may want to opt into pre-rendering the pages or using server-side rendering. If you have slow loading times, initial loading times, most probably you're once again using client-side rendering, just run everything on the server, therefore reducing the bandwidth between the front end and the back end, and delivering a quicker initial loading experience. And if you're experiencing high running costs, well, you're obviously running a server-side rendered application, and those users are growing and therefore demanding more computing power, which is costing you on your monthly AWS bill. So you might want to ship that to the client. Just choose client-side rendering. Fortunately, we're living in 2022, so we're not limited, if we're using the latest technology stacks, we're not limited to choosing a single approach for the whole application. And that was the case up to a few years ago. Currently, we can choose to deliver different parts of our application in different ways. For example, if we take as an example our, let's say, landing page or index page, or some sort of an about us page with all the executives being listed and our contacts, we can pretty easily get that a static site generator, because this is static content. We do not expect, like, let's say, the contact us page to change, or if we change it, it would be like, let's say, once a year. So we can choose static site generation for those parts of our application. Let's say we have some sort of a social network, so we have a relevant newsfeed with posts and comments, likes and whatnot, or a shopping cart, so a dynamic thing in nature. So we may want to choose server-side rendering when it comes to delivering that part of the application. And if we were to have some sort of a very complex flow, including an editable list of items, let's say some fancy table, or a complex flowchart with drag and drop functionality, resizing and whatnot, chances are that by this point, the user has already been using our landing page, let's say, so the initial app experience has been great for him. And at this point, it may be a good idea for us to deliver a better experience in, let's say, the complex flowchart part of our application by just shipping a bigger JavaScript bundle when the user enters that part of our web application. So we can leverage the power of client-side rendering for that. All right, up to now, we first of all began with talking about the history and how kind of history repeats itself. Then we went through the actual current setup of the web when it comes to those three rendering strategies. Now let's try to see if we can improve things or where things are headed in the future. In order to do that, let's first of all begin with static site generation. Can we improve that? Can we make it a bit better? Well, as I mentioned, the main drawback of static site generation is in the name. It's static. If we want to deliver anything dynamic, we may want to regenerate all the pages every, let's say, 5 minutes, or once a day we can generate all the pages once again, therefore delivering a better, more interactive dynamic experience. For server-side rendering, notice that we have a delta between the FCP and TTI. This is most of the hydration scripts that are going on. So maybe we can try to split those scripts and deliver them in smaller sizes, so chunk by chunk somehow, and therefore deliver better experience once again. And for client-side rendering, the bottleneck is kind of obvious. It's once again a huge JavaScript budget. And most of you are probably familiar with the chunking of that bundle, just getting it into smaller bite-sized pieces and delivering them one by one as needed. So let's discuss those future possibilities here. Starting with static site generation, and the concept called static site generation revalidation. Revalidation stands for, making something invalid after a certain event. So as I said, we can have some sort of a trigger, which would be an interval trigger. Let's say, imagine once a minute you regenerate a certain page because you expect that to change a couple of times during, let's say, the next hour. So you kind of choose to regenerate the static page every 60 seconds or so. Or you may have an event trigger. Let's say, imagine that you have a web browser and we have some sort of a contacts page, and one of the executives gets a new haircut and wants to be showcased with her new hairstyle. What you may want to do is mark the old page as invalid after that event has happened, and now things are shown as needed, and our stakeholders are happy and everything. In terms of code, and keep in mind that it's pseudocode, But somewhere, if you're using a recent technology stack, you may find a configuration for each individual web page, configuring some sort of a revalidation field. And in this case, each static page marked with a revalidate of 60 would be generated again and again and again, continuously, once a minute. Or the case about adding a new manager to the company. Let's say, imagine we have the About Us page and we have all the managers, but we have a new one. And after that event has happened, so let's say something has been added to the database, you may choose to revalidate the About Us page so that it reflects the latest situation inside of our company. Okay, we mentioned things to optimize when it comes to static site generation. Let's see if we can do something about client-side rendering. And as I said, most of you are probably familiar with that, but we're talking about code splitting here. Code splitting is, for all intents and purposes, grabbing that bundle and dividing it into smaller bits, so it's kind of easier and more performant to deliver it as the application goes. So you can choose to do that by dependency. So let's say we have a very complex flow charting library that we want to deliver a bit later. We may choose to do that as a chunk and deliver it later on. So in order to leverage code splitting. Or we can make a decision. We can say that each individual route inside of our application, so each time you enter a new URL inside of our application, we'll be delivering the JavaScript for that as a new chunk. So doing that by decision, by a developer decision. Let's take a case with having that fancy chart going on. So imagine that the chart on the right, showcasing the brilliant performance of our colleague here, is really heavy, let's say 500 kilobytes, and you want to deliver it later on. You can leverage some sort of a syntax, roughly looking something like this. You dynamically import the part of your application as it's needed at a later point, and after that has been completed, you will initialize that chart and everything would be good to go. Until that, you have some sort of a spinner going on or something as a placeholder for that content. Okay, we talked about improvements in static site generation and in client-side rendering. Let's see if we can do something about server-side rendering. Let's have a look at our application. Let's say that we delivered that website. What can we do? First of all, we notice that we can kind of logically divide it into pieces. So we can say that the essential piece of our application is, let's say, the search bar and the navigation bar. Then we have, let's say, the picture gallery with some information, and we have the advertisements section to the right of it. So in most cases, we can kind of draw boundaries between parts of our application, and they have different purposes, because obviously the search bar is way different and serves a whole different purpose when compared to, let's say, the gallery that we see below it. So what can we do here? We can leverage a relatively new concept in web called streaming server rendering. And this is probably the cutting or bleeding edge, or however you want to call it, currently in 2022. Streaming server rendering is a fairly old concept, but it's reliving its renaissance right now. The idea is, as I said, you divide your interface into logically divided pieces. And in this case, let's say you want to deliver the header, including the search bar and the navigation bar immediately, but then you mark the blue, let's say, rectangle and the purple one as things that can be side-loaded or loaded later on. And let's say, as I'm mostly using React right now, in React 18 and above, you can even have the following functionality. If the user interacts with something which has not been yet hydrated, so which is not fully interactive, it can be prioritized by React so that it is hydrated before everything else, therefore delivering as optimal of a user experience as possible. Because you load the web page, the user sees some stuff, because remember, we're using server-side rendering. And as soon as the user clicks on something, that part of the web application is prioritized by React, the React core, and it's the first thing to get the hydration piece so that it will become interactive. And the difference or the delta between the user seeing something on the screen and clicking on it, and then actually something happening is as minimal as possible, delivering the best user experience. So in this case, let's say the user interacts with the blue part, it's immediately loaded, and we still have the purple one waiting. As far as code is concerned, what we're doing with SSR boundaries, we're mostly doing two things here. We're either partitioning So grabbing our user interface and kind of dividing it somehow logically into different parts. Or grouping. Grouping is basically getting some partitions and deciding that they're cohesive together and marking them as a larger group. In terms of code, if you are to look at, let's say, your HTML structure that you would be eventually shipping to your client, it may look something like this. But most probably, stuff like the posts and the comment section are the heaviest and therefore would be taking the longest to hydrate. So you may choose to wrap them in some sort of a boundary. The boundary in React is called suspense, for example, and you just give it some sort of a fallback. Or this is the thing that will be displayed during the initial loading, but then that would be minimal because you're, after all, leveraging server-side rendering. So, I'm running for 47 minutes at this point. But we are here to answer a pretty simple question. What do we choose? Do we go for client-side rendering, or do we go for static-side generation or server-side rendering? And like the key takeaway, or the one thing that I wish you to take as information from this rant of mine, would be just follow this fairly simple decision tree. When you're encountering a new application, or if you have some sort of a problem with some sort of the user experience, for example, ask yourself the following questions and try to see if you can optimize things. Do you have dynamic content inside of that part of your application? Is that web page dynamic? Let's imagine that it's not. It's the contacts view page. Go for static site generation. You will have all the benefits. You will have static content already ready waiting for you on the server, which will be delivered as fast as possible and as efficiently as possible. On the other hand, more often than not, you will need to have dynamic content. The next logical question here would read something like, do you have problems with search engine optimization, or do you need fast initial loading? Because you notice some of your users are complaining about that. If you do not care about those things at this point, at this place in your application, choose to go for client-side rendering. You will be shipping a relatively big JavaScript bundle to your user, but that will be a problem more often than not because the user is already using your application and he can wait a few seconds for that very fancy part of your web experience to load. But more often than not, you need fast initial loading, and search engine optimization is crucial because after all, that's how our products are found on the web. So, go for server-side rendering in most cases if you need fast initial loading, search engine optimization, and dynamic content. With that being said, once again, I'm Nick. I'm a part of the team at Obsidian, a Bulgarian consultancy agency. I would like to thank everybody here today, especially the organizers of GS Talks, and I'll be more than happy to answer your questions in the remaining couple of minutes. Thank you. Do we have any?
Просто креща. А микрофон, нещо?
You're using Angular, if I got you correctly, and you're curious about?
Дай ми да кара микрофончик.
Yeah. Well, the question, just to repeat it here, is roughly, the colleague here, she's using Angular and she's using static site generation, if I got you correctly, right? All right, what would be the pros and cons? Well, the biggest con is it's static, it's not dynamic. I mean, you cannot have, if you need to deliver information specific to your user, let's say you want the specific page to look different for different users of your web application, you obviously cannot have static site generation because it's kind of hard-coded from the very beginning if you're choosing to go that route. But the main pro is that the asset or the HTML is already done and cached on your server. You may choose to go for, let's say, edge location delivery. So to choose some sort of a content delivery network, you have options in the cloud, for example, for doing that. And that will deliver the best loading times because at the moment that your user is opening that application, a request is sent for essentially a static file. It's already there, it's already generated, it's as small as possible. You do not have any rendering or parsing logic, because most probably you have very little bit of JavaScript in there, and that will result in a fast user loading and fast initial loading experience. But after that, it's static. So that's what I would say are the biggest benefit and the biggest drawback. Things being static and things loading fast. But we can discuss that later on if you'd like. I'm in the booth at Excedia, you can come by. Okay, thanks.
One more question.
Yeah.
From over here.
Thank you.
First of all, great talk. Really well presented. We will be referring to this internally. Second, the question that I want to ask you is, are you currently using Next or Angular Universal? And there's going to be a follow-up question after your answer.
I'm a React user. I'm mostly using Next.js. I have used some Next, I have not used Universal.
All right, so if you're using Next, are you leveraging the on-demand ISR, which is the static site revalidation, incremental static regeneration?
Yeah, both of them. Pretty much, I'm trying to leverage even some events. So, for example, listening to some, let's say, database changes or some webhooks or whatever to revalidate some parts of our web application. But mostly we're using revalidation with a time period, let's say a couple of hours or once a day we're regenerating parts of our web application.
All right, then I suppose you're hosting on Vercel.
Yeah.
Right. Thank you. Great talk.
Thanks.
And there's a mic if there are any other questions here.
Or you can find me later on.
I can deliver the mic to whoever wants to ask the question next.
Unfortunately, I think that we need to go. Right. We're kind of running late. Thank you once again.